So in the last lesson, we learned what regressions were, and now we're going to learn how to use them to actually solve some real world problems, kind of like the ones we've been doing earlier in the unit where we have problems. So it says real life data often forms patterns that can be modeled with functions. For this course, we will be looking at data that can be modeled by linear and exponential functions, as well as trig functions, and that should say in 2 units, not next unit. Below is a summary of what to look for when deciding if data should be represented by a linear function or an exponential function. So when we look at data, and we already know this, we see a straight line, it's going to be linear. We know linears are in this form. So if something has a constant rate of change in a start value, that's linear, a constant numerical rate of change. So we look for the plotted data to resemble a straight line, and this could be positive or negative. When we're looking for exponential modeling with data, we are looking for something with a constant multiplier or a constant percent change. We're looking for curves that are shaped like this, right, in one of these 2 directions, right, more with that exponential curve, not a straight line. It says, does the plotted data appear to grow or decline by percentage increases or decreases? Multipliers, remember the shape of the exponential function, and for these graphs, we can't add on a vertical shift up or down, which would allow the range to go below 0. So we're also looking that for this to work, the y values have to be greater than 0 for regression on our type of calculator. So we're going to look at a couple scatter plots before we start to look at the word problems and just decide if they're linear or exponential. So if I look at these, hopefully this is pretty easy for you. I might just jot down an L or an E on top of each one, pause the video and then come back. This one has that exponential curve. This one, straight line, and the linear ones can go to y values that are negative. That's not a problem for ax plus b. Linear, and then this one is a decreasing exponential. So now we're going to look at the actual word problem, and the first thing we're going to need to do, a lot of times on the regions, it just says make a linear regression, find an exponential equation or exponential regression, but here we're going to decide from the data. So I have down reading exercise 2, create a scatter plot for the data. Based on the scatter plot, what type of function would best model this data? So I have maybe a scientist observing the growth of bacteria, and that's after how many hours, how much bacteria is there. So I actually already put the information into my table. If you need to go back over that, you just go to stat edit, and I typed in that data. Now for the scatter plot, we start with typing in the data. The next step, I'm looking at the top step, says press y equals, move your cursor up to plot 1, and press enter. So sometimes you guys have had that on in class, and it's messing up your regular graph. That's the stat graphs. So that's on now. Now the default stat graph is a scatter plot, so we don't have to change settings in, there's a second y equals a stat plot. Now I need to press zoom, and at the bottom of the zoom menu, I see zoom stat. That zooms in on the points in my table that I entered. So zoom 9, and then we see the scatter plot. So for our purposes, we are not trying to find scales. We are looking for a pattern. So I'm just going to draw this over here. I'm going to do the best I can to kind of eyeball it. Not moving the axes. Okay, this is not great. Okay, I made it a little too exponential looking. Hopefully you guys get the idea. It's hard for me to see both and on the smart board. I guess it's not awful. So in this data, I see that exponential curve. And this point here should probably be a little bit lower, so it looks a little more exponential, but it's pretty clearly exponential. So what we're going to do based on that, we're going to move down to exercise 3 and read that. I do want to point out on the calculator that if I go to window, I can see the actual window. So the x values here go from negative 0.5 to 5.5, and the y's go from negative 63 to 593. And that makes sense because my biggest value, y value is in the 500. So it's just finding these points and picking a good window for that. So now we have a little more information about the problem. It says a scientist in the laboratory, I'm reading exercise 3, collected data about the number of bacteria in a sample. The results are recorded in the table below. Based on the scatter plot, what type of regression would best model the data? So we see that that's exponential. The context of the problem, we also know bacteria typically grows exponentially by multipliers, not linearly. So based on that, I'm going to find the appropriate regression equation with the coefficients rounded to the nearest hundredth. I'm only going to do this one regression today, on this lesson. The other ones, I'm just going to kind of say, we got them, okay? Remember, you can also use Desmos. So I go to stat, calc, and 0 is exponential. I talked about that in the last lesson. I could also scroll down to find it. And we get, for our equation, to the nearest hundredth, so 20.51 and 1.92. So y equals 20.51 times 1.92 to the x. Using your regression, now we're going to start to make some predictions. So we have this equation. I do notice that this is almost doubling. It's almost a 2. We're growing by 92%, I could say. And we're going to start to use that. Now, actually, before I go on, I want to show you there's a website. Delta Math does not let you do regressions, but I found a website called alcula.com. You could search for it, and it has, so if you did alcula.com and scatterplot, this would come up, and you can actually enter points. So this one's not too long. Now I have my points entered in. You can submit the data, and it will create a scatter plot. It's actually a little nicer than the calculator because I can see the scales. So it's a nice feature. I see about that same window that we saw before. So that's an option if you don't have a calculator at home. Going back to the problem, we are going to make some predictions. It says using your regression. So this is that equation of best fit. How many bacteria will be in the sample 4.5 hours after the observation began? So the first thing I need to do is decide to do is what to do with that 4.5. And 4.5 would fall in the x values. And I'm looking for the y value, which means that x here they've given me as 4.5, and I'm trying to find y. So I'm going to plug in that y value to the 4.5, and then I can just basically type that whole thing in my calculator and figure out how many bacteria will be there. So to the nearest whole number, it's 386 bacteria. So this has, I think we get this probably, but this is not in the stat menu. I'm just typing this in the home screen like a normal evaluation. The next one says, using a graph of your regression, after how many hours to the nearest tenth of an hour will there be 2,000 bacteria in the sample? So this one is kind of tricky. I'm trying to see when does it grow to 2,000, and I'm trying to use a graph here because we haven't learned how to solve these algebraically yet. So what I'm going to do is I'm going to graph in y1, 20.51 times 1.92 to the x. This 2,000 is a number of bacteria, and I'm trying to find the x. So this is a y value, so I can also graph the 2,000 in y2. So I'm going to go over to the calculator and go through that process now. Now it's fine if I leave my scatter plot on there. And it's also kind of nice to see that those points do come really close. They're not all perfectly on the line. It is a line or a curve, the curve of best fit. I don't see the 2,000 because my window only goes up to 593. So I'm going to make my Y max so I can see this 2,000, maybe 2,500. So I can see that out here to the right, I'm going to need to move the x's over so I can see where this blue function comes up to the red. So I'm going to make this, I don't know, 15 maybe. Okay, I didn't even need to go that far, and that's because of how exponential functions work. They grow very quickly. So then I can go to second calc intersect, enter 3 times, and I get that the intersection point is 7.02 2000. So just to show my work, I don't need to draw my graph or anything. I'm just going to write that I found the intersection and that was 7.02 2000. So to the nearest tenth of an hour, that is 7 hours. It rounds down to 7.